All right, let's finish these notes up today. So the next thing we want to look at is just what's called function operations. So when you think about operations in mathematics, that just means adding, subtracting, multiplying, and dividing. So the idea here is, what does it mean when you see f plus g of x? Right? That really just means f of x plus g of x. And so there's some confusion in this notation, though, because a lot of times people think that this is saying that the x is distributing. That's really not what's happening. It's just a notational thing, but it certainly I can understand why it's confusing because it looks like distribution. But basically all it is saying is, whenever you have f plus g of x, that just means you're adding the two functions together. Don't think of it as distributing the x, because a lot of times then people want to put an extra x in there, right? So don't make it harder than it actually is, right? Really and truly, all it's saying, when you want to add two functions together is quite literally, this is just saying take the two functions and add them together, right? That is as easy, that's all it means, okay? So I know that when you see that f plus g of x, again, the way we read that is just of x, that really is just saying, well, that means I could take f of x and add it to g of x. Of course, we could combine some like terms if we wanted to, right? So then this would become what, x squared plus 3x minus 3. So that would be a simplified version of f of x plus g of x. And you might say, well, what's the point of this? And so the idea here is that, let's say you actually wanted to use a value. So like f of 2, right, plus g of 2. What this is saying is that I could just find f plus g of 2 and it'd be the same thing, right? So like if I were to come up here and plug 2 into each of these functions, right, so f of 2 would have been what, 4 minus 1, so 3, right? And g of 2 would have been what, 4 plus 2 is 6, minus 2 is 4. So when I add those together, 3 plus 4 is 7. Whereas if I would have just plugged 2 into the new function down here, right? So if I plug 2 into this, then I would have gotten what, 4 plus 6 minus 3, which by golly, that's also 7, right? So it's basically saying that, you could individually plug into the functions, or you could get this new function that is what f plus g is, and then plug into that, okay? And then as far as the domain goes, basically the domain is just the intersection of the two. Okay, so all that means that if you look at each individual function, then you would say, well, what's the domain of f? What's the domain of g? And so then the domain of their sum is just the intersection of the two. And a lot of times with this example for, f doesn't have any limitations on it, right? Since this is just a linear function, I can plug anything into that. And since g is a quadratic, I can plug anything into that. So when I add the two together, it's just a quadratic, so I can plug anything into that. So my domain is just all real numbers, right? So negative infinity to infinity. And so a lot of times, again, if you're not sure, that's your assumption. Unless you see a fraction or square roots, it's just going to be all real numbers, okay? So then real quick, if I want to subtract, right, same idea. If I want to subtract two functions, really then this notation is just saying f minus g of x is the same thing as just subtracting the two functions individually. So the main thing with subtraction is, right, so if I wanted to do f minus g of x, the main thing is that f comes first, so that'd be 2x minus 1, and then when I subtract, I'm subtracting all of g, right? So x squared plus x minus 2. So that just means that's going to distribute, right? So 2x minus 1 minus x squared minus x plus 2. So we just have to be careful of the distribution. That's really the only thing there, okay? So what's that going to be? Negative x squared. If I write it in descending order. 2x minus x, so that's plus x, and then negative 1 plus 2 would just be plus 1. And again, both of those functions have domains of all reals, so therefore the domain of the difference, the subtraction of the two, is still going to just be all reals. Okay. If I want to multiply, same thing. Right? So f times g of x just means take f, which was 2x minus 1, and multiply it by g, which was x squared plus x minus 2. Now, if you wanted to, right, you could actually multiply this all out, right? So you could distribute the 2x, so we'd have, what, 2x cubed plus 2x squared minus 2x. Then distribute the negative 1, so negative x squared minus x plus 2. So that's going to end up giving us 2x cubed plus x squared when I combine those two, and then minus 3x, and then plus 2. So to multiply f and g, I've created this new function that would do that for me. So again, the idea here is that, I could individually find out what f of 2 and g of 2 are, and then if I were multiplying them, right, I would have gotten 3 times 4 is 12. But what this is saying then is if I plug 2 into this function, I would just get 12 with the new function, right? So that's basically all we're doing here. All right, and then again, my domain's just going to be all real numbers. Okay. And then last but not least, division. And a lot of times division is in some ways the easiest, because a lot of times when we go to divide functions, there's really not much we can do as far as simplifying goes. We quite literally just say, well, it's 2x minus 1 over x squared plus x minus 2, and I'm done. Right? There's no way to simplify that. I can't cancel anything, and so I'm done. But the one thing with domain that we have to be careful of with division is that we may actually have some issues, because now that we've introduced a fraction, right, I cannot divide by a zero, right? So since I can't divide by 0, I've got to sit here and say, well, are there any things that would make that bottom 0? Now, again, I could guess and check it probably, but I could also just think, well, what would make that quadratic in the bottom equal 0? So what's going to multiply to negative 2 and add up to 1 would be a positive 2 and a negative 1. Right? I would multiply to negative 2 and add up to positive 1. So when I set each of those equal to 0, right, x plus 2 equals 0 and x minus 1 equals 0, then I find out then that if x is negative 2 or x is 1, that would cause the denominator to be 0, and I don't want that, right? So my domain here, I could say it's all real numbers, but x is not allowed to be negative 2 and 1, right? So when I have division, I do have to now watch out, because now that I'm dividing, there are some values of x that I might have to throw out, okay? So, individually, negative 2 and 1 are totally fine in the functions f and g, right? If I come back up here, I can plug negative 2 into f. I can plug it into g. I can plug 1 into f. I can plug 1 into g. That's not an issue, right? The issue is that now that I've created division, when I put negative 2 and 1 into this denominator, right, that is going to create 0, which I can't divide by. So when we do division, we've got that extra one. Okay. All right. Last but not least, we've got a couple more here with radicals, just to take a look at the domain issues. So when I'm dealing with radicals, right, the great thing is if I want to add these, it quite literally is just doop and doop, and I'm done, right? I can't add those. Like, I can't simplify anything. A radical plus a radical is just that. right? So the great thing is that f plus g is that. But for domain, it can be a little bit trickier. So that's why we actually want to look at this one, be more a little bit more interesting with the domain. So for the domain, it's saying, okay, well, let's take a look at each one of them individually. So let's take a look at the domain of f, right? And so for f, it was the square root of x plus 3. So what we saw yesterday, right, was this idea that if I have x plus 3, I know it has to be greater than or equal to 0, right? Because I can only take the square root of positive numbers and 0. So when I solve that, I find out that for the function f, I can only use numbers greater than -3 or equal to -3, right? If I take a look at g of x, I know that 2 minus x, what's underneath the radical, has to be greater than or equal to 0. And so when I add x to the other side, I find out that it only works for values less than or equal to 2. So now when I go to do the domain of the sum, I basically want to look at both of these. And so a lot of times one thing that's nice and easy to do is think about number lines. If I, for f, it's saying that I can do anything from -3 and above, right? And then for g, it's saying I can do anything, change colors for g. For g, it's saying, hey, you can use anything below 2. Okay. But if I think about those together, let's see if this actually works. Woo. Hey, look at that. Kind of did, right? What is it that works for both, right? So the numbers that work in both situations would just be the numbers from -3 to 2, right? So if I plug in anything greater than -3, that's going to work for f. If I plug in anything less than 2, that's going to work for g. But in order for me to look at the addition of the two, it has to work in both, right? So in order for it to work in both, it has to be a number between -3 and 2. Okay? And so if I go to do division, it's the exact same idea. So this time it's telling me f is on top, so that would be radical x plus 3 is on the top, and then radical 2 minus x is on the bottom. Right? But the only difference here is so again, the domain of f, so same idea as before, domain of f was greater than or equal to -3, and the domain of g was less than or equal to 2, right? And so as we just saw, if I pick anything bigger than -3, but then I need to be less than or equal to 2, then I'm going to be looking at, again, this little section here. And so you might say, oh, well, gosh, Mr. Chandler, that's a piece of cake then. I guess it's just the exact same, right? However, we've got a fraction again. Fraction. I hate when it does that. Cannot divide by 0. So when I look at this situation, if I plugged in anything from -3 to 2, I'm going to be okay. I can plug that into my toaster, except we have an issue right here at 2, right? Because if I actually plugged in 2 to the bottom, this would be 0. The square root of 0 is 0, and that would be bad. So we're going to have to make a slight adjustment here. At 2, right, it's actually just less than 2. I can only pick things less than 2. I can't pick 2 itself, so I'm going to change this to a parenthesis, right? So this is saying I can plug in anything from -3 to 2. I can pick -3 because that would make a 0 up top. And 0 on the top is fine, right? But if I put 2 in, that's going to make 0 on the bottom, and that's not okay. So we just have to kind of think through logically what's going to break the toaster or not, Okay, what's going to make the machine work? What's going to make the machine broken? Okay, so that's about as tricky as they get there. All right, let's just take a quick look at a quick application. It says the following function models the number of births and deaths in the U.S. in thousands over the course of 2000 to 2011. X is the number of years after the year 2000. And so we have this model here that is going to give us, that's the number of births that occur. This is the number of deaths that occur. And it says write a function c of x that models the change in U.S. population. So if I wanted to come up with this new function c of x, right, then I could say, well, what would the change in population be? Well, I would think that maybe the change in population would be if I were to take the number, so if the change, right, would equal the number of people that are born, the births, minus the deaths, and that's going to give me my change in population, right? So in other words, then the function c of x is b of x minus d of x, right? So in other words, that's right. I thought I had my letters wrong. All right, I got all thrown off because those are my initials, B, D, C. All right, you can try to guess my middle name. First name's Brian, middle name, try to guess it, starts with a D. All right, so b minus d will give me the change. So if I were to just take this function b, right, and subtract this function, then that's going to end up giving me my change. Right? So if I did negative 2.6 x squared minus a negative 0.6 x squared, that would change it to a plus 0.6, right? So that's going to give me negative 2 x squared. And then if I do 49x minus 7x, that's going to be 42x. And then if I do 3,994 minus 2,412, right, that's going to be what? 2851. So 1582. So there's a new function that will model the change in the U.S. population in thousands. Okay, so it says use this function to find the change in the population in the year 2008. So does that mean we're going to plug in 2008? No. So we have to go back here and look. X is the number of years after 2000. So always be careful to see how your function is defined, right? So this actually means c of 8. So we'll just plug that in. Negative 2 times 8 squared plus 42 times 8 plus 1582. For the first time, we're going to actually need a calculator here. Do I have my calculator? There we go. If you haven't lately, I would make sure that the old Desmos graphing app and the scientific calculator apps are both on your iPad, so they're handy and easy to use. So we've got negative 2. Of course, calculator, if you've got your TI Inspire, you can try to find the charger for it, right? 42. We'll talk more about what you're going to be allowed to use and stuff when I get back. Okay, so negative 2 times 8 squared plus 42 times 8 is 1582. So it looks like 1790. 1790. All right. So I guess, wow, that's not bad. Oh, but remember, it was in thousands, right? So this is actually 1,790,000. So if I add on the zeros, right, it's actually, right, 1,790,000 people was the change, right, in the year 2008. Right? So in the year 2008, it was a positive number. So that means that the change was actually a positive, right? So there were more births than deaths. And so if there was a particular year where the number came out negative, then we would actually know that in that particular year, the U.S. population went down. Okay? All right, so that's that. So give the rest of the problems a try on the worksheet and see what you come up with. There is one other symbol that's on the worksheet, and little open circle. So that actually means to compose. And if you don't remember what that means, it's okay. We'll talk about it more when I get back, but I didn't want these notes to be too long, so we'll just stick with that for now. But if you have like F little circle G, okay, see if you remember what that means. So talk to your partners in crime there at your tables and see if you can figure out what exactly that might have meant to come up with. All right, I will talk to you.